Rice blast disease caused by Magnaporthiorizae is one of the most destructive diseases of rice. In the Philippines, there is a big demand for this crop because the average diet is based on rice.
The rate of growth of rice production, however, has slowed down. Rice crop loss and rice crop diseases are now the main concerns in rice crop production.
Rice blast fungus is one of the several diseases that affect pre- and post-harvest quality, thereby reducing biological and economical yield.
On the other hand, mud crab shell is a product that is often disposed easily once the meat in it has been eaten. Since crustacean species are loaded with chitin, great load of chitosan can be yielded from them. This motivated us to conduct this study entitled
The Effect of Chitosan Derived from Mud Crab Shell in Controlling Rice Blast Fungus in Vitro. This study was conducted to determine the effect of chitosan derived from mud crab shell in controlling rice blast fungus in vitro.
This study is a laboratory experiment conducted to assess the 3 different concentrations of chitosan when compared to chemical fungicide.
This study was led using the complete randomized design and was composed of 5 treatments and 5 replicates.
25 full-grown spores were made available for the treatment application. There are 5 treatment groups in this study. Treatment 1, the 75% chitosan. Treatment 2, 50% chitosan. Treatment 3, 25% chitosan. Treatment 4 is the positive control diethane, and treatment 5, the untreated group.
This table was used as a guide in the formulation of the chitosan treatments. The solutions were prepared using this formula.
The treatments were applied 6 days after the inoculation of the casual organism. Each petri dish was inverted such that the top cover where the pathogen was lying face downwards. Then the seal was carefully removed while placing it over an alcohol lamp.
Only half of the whole tape sealing the petri dish was removed to create a small chamber. On the first drop, 1 ml of the solution was properly applied aseptically on the treatment by using a sterilized transfer pipette. On the second drop, another 1 ml again was applied.
The pathogen growth was evaluated by measuring the pathogen diameter in millimeters. Using a foot ruler, the diameter of the pathogen was measured from 6 points, namely A1, A2, B1, B2, C1, and C2, labeled in each petri dish. The mean of the 3 streaks was computed as the diameter of the pathogen.
The difference of the initial and the final diameter of the fungus was interpreted based on the table shown.
Table 1 shows the mean table differences of the fungi as affected by the different treatment groups after 7 days. As the table manifests, treatment 1 75% chitosan showed the best performance in fungi growth inhibition, which suggests that the concentration of the chitosan is proportionally effective to the treatment.
It shows that the p-value is lesser than 0.05, hence the alternative hypothesis is accepted. This implies that there is a significant difference between and among the treatments used in terms of the fungal pathogen growth. Based on the results, findings, and observations, it is therefore concluded that the 75% chitosan significantly decreased the diameter of the rice blast fungus in vitro, and there is a significant difference between and among the treatments used.
It is then recommended that the chitosan should be considered and used as potential biological control for rice blast fungus used by the farmers.
I am Rose Melchamain Daiwan.
And I'm Jacob Philip Galsote. The effect of chitosan derived from mud crab shell in controlling rice blast fungus in vitro.